Okay, guys, this is just a quick review of some of the concepts that I'm seeing students have trouble with. The first thing is the difference between an element and a compound. An element is a single element, for lack of a better term, from the periodic table. It is a single atom. It is not multiple atoms. A compound, on the other hand, is one or more elements joined together physically and chemically such that they cannot be separated without a chemical reaction. So anything on this table is considered to be an element. Everything on this white section here is a metal. These gray ones are considered to be a non-metal. And along the step line, you have some of the semi-metals. Sometimes they're called metalloids. The exception to this is hydrogen. Hydrogen is the only nonmetal that can be found on the metal side of the periodic table. Now here's where this comes in is important. You can have a single atom by itself, but you also can have something like O2, which is a non-metal element because it consists of only one element. There's not more than one different type of element connected. You also have these. This is not an element. This is a compound. Okay? Most of the time, your metals will be just sitting beside themselves. So here's an example of a semi-metal that's acting like a metal that's sitting by itself. It's not joined with anything else. It is a metal element. This is a compound. This is a compound. This is an element because it is only hydrogen. Only H is in this. Don't pay any mind to the 3. That's just to balance it, the coefficient. Or the G. That just tells you what state it's in. It's gas. But the H tells you that it is only one element. Now, this brings up the next conversation of the 3 different types of compounds that you could have. Okay? So, you have elements. You put more than one element together. You now have a compound. You can have 3 different types of compounds. You can have a molecular compound that consists of elements all from one side of the periodic table that are nonmetals. You could have an ionic compound that has a metal and a nonmetal, which is 2 things from 2 different groups, or you can actually have metallic, which is when you have more than one element from the metal section of the periodic table. So a good example is this. This is a compound because it is carbon, oxygen, and chlorine. Let's be clear, that's carbon, oxygen, and chlorine. It is not carbon, oxygen, and iodine. It's carbon, oxygen, and chlorine. Remember that capital I's, when they are typed, do not look quite like this, okay? A good example is to always use your point of reference. Look at your table or look at your paper. So if I look at this particular paper, there's a lowercase I here. There's a lowercase l here, and there is a capital I here. Notice that this I looks different from this letter here. This is an L, just like this is a G and not a Q. Generally speaking, how can you tell? So this is a G, but look here, this doesn't look the same. It's a Q. You can very easily use your actual paper that you have to find clues as to whether something is an I or an L, okay? You have to use your clues. Just be very, very cautious in jumping to the conclusion that that is an I, a CI, because it is definitely a Cl. Also remember that in the periodic table, the second letter of any formula is written as a lowercase. So if you write it as a capital, then it is wrong, okay? A good example of that is this here, this CO. The C, capital O, tells you that this is 2 different elements. It is both carbon and oxygen. This is a covalent compound. It is not cobalt, which can be found here on the periodic table with a capital C and a lowercase o. The second letter of any element is always going to be smaller than the first. And if you see that they are the same size, one is not capital, or they're both not capital, if you see that they're the same size, that means they're both capital. If you see that one is, a lowercase, that means it is one capital, one lowercase, that is one element. Two capital letters, that is two separate elements, okay? I think that that's just about it as far as most of the misconceptions that I've been seeing in terms of reading the periodic table and the elements that are on the periodic table. The next thing I wanted to discuss with you is compounds. So when we have a compound like this is a balanced equation. Sometimes you will have a balanced equation, sometimes you'll have an unbalanced equation. Unbalanced equations do not have the same number of atoms on both sides. So if I took away this 2 here in the beginning, this is an unbalanced equation because they are there's one Na and one Cl on the reactant side, but there are one Na and one Cl, 2 Cl2s on the reactant side, okay? I add these 2 here in order to balance it. Make sure that you're proving why those numbers are what they are with a tally. Now, it's important for you to understand that this is a chemical change. I know that it's chemical change because I'm going from a compound to 2 elements. What's on this side is not the same as what's on this side. That's a chemical change. Now, this is an example of something that is a physical change. I'm taking this sodium chloride, I'm adding it to water, and it is now sodium chloride aqueous. We know that aqueous means that it's simply just dissolved in solution. Another example of a physical change. Here, this water is ice because it's solid, and I am melting it, and so now it is liquid water. That is a physical change. When I have the same compound on the left as on the right, it is a physical change in the symbolic nature. If I look at this last one, though, this one is a chemical change. I've gone from a covalent or molecular compound, covalent and molecular mean the same thing, to 2 elements. I know these are 2 elements because the H2 is by itself, the O2 is by itself, and when I say by itself, I mean it's not directly joined to another element. I went from something that is liquid to something that is gas, and so therefore it is a chemical change. Not just that I went from liquid to gas, but rather I went from one liquid to 2 separate gases. Okay? So when the formula is not the same on the left and on the right, that is a chemical change. I should also add that this is not balanced. Okay? If I look carefully, I have 2 H's on this side. I have 1 O on this side. On this side, I have 2 H's and I have 2 O's. In order to balance this, I would need to at least figure out how to get those O's together, and I cannot split this in the middle, okay? So I'm not allowed to split it in the middle. So let's see, how could I do this? I definitely need to have 2 O's on this side, so let me just do this. So that gives me my O's. My O's are balanced, but this also changes my number of H's to 4. So now in order to balance this, I need a 2 here. Remember, sometimes in these balancing problems, you have to go back and forth, and that is A-okay. Going back over your work to check it and to make sure it's right and make corrections is not a problem. Also, make sure that when you're balancing your equations, you're looking for the lowest possible number. So 4, 4, 2 is a possibility, but I'm always going to give you the lowest possible number available on the test. That's the right answer. All right, I think that's just about it in terms of chemical reactions. The last thing that I want to go over with you is physical and chemical changes. We did that in the symbolic. I also want you to look at it in the submicroscopic. So in this particular case, I'm going from a solid to a liquid. This is my beginning. This is my after. This is a physical change. It's a physical change because I've not regrouped anything. I've not made any new bonds. I just kind of spread things apart. This here, though, is a chemical change because I've taken a compound and I've broken it up. This is a chemical change. Okay? Not to be confused with this here, which is simply a physical change. Okay? Let me zoom out just a little bit so it's a little easier for you to see. So the only thing that's different between these two is in this one, these dark gray ones, they are compounds. Well, not compounds. They're two of the same thing joined together, and I have one by itself. And at the end, I still have two of the same thing joined together, and that same one that was by itself is by itself. The only difference is before it was a gas floating around, and now it's a liquid confined to the bottom. So don't be fooled by the fact that there's more than one thing in there to show that it's a physical change. I think that's just about it, and good luck on your test on Monday.